Good morning, everyone. I hope the audio is a good level. It's a little bit hard for me to tell right now because everything's sort of missing from my office. So I moved out my microphone, the normal webcams. This is just like a webcam in my streaming PC. And I think it's going to be, well, it's definitely going to be temporary. But I think hopefully before the next stream, definitely before Monday, I will have sort of set up things for a lot better for streaming. Big Oinky, good morning. Oh, of course, my phone down here is still reconnecting to chat forever, so that's cool. Go to dashboard, connect for real. There we go. How audio is fine? Okay. I'm using these Wi-Fi or wireless headphones for audio today. I was trying to set up like the computer for it, but then the fan kept on going, and that was clearly not gonna be good. So let me close all of you down. Let's see. Go to code, books, builds, nature of code, ecosystem project. Let's open this up in VS Code. All right, so last time where we left off is we got the walkers to stay in the arena, and we did that using a trait. I was like looking left for the camera, but the camera is this way now. Um, so we have the walkers are all sort of like wrapping around and staying in the arena, and it's the same piece of code that works for both of them. So I think that's really, really cool, and that opens us up later on to changing things around, and we don't have to change it in two places. Uh, the next thing to work on is making it so that the walkers can eat each other. Right now they don't do that; they just sort of ignore each other and just go after the food. And I think we can work on that a little bit. Uh, let's see. Okay, so right now, the way that the walkers eat, uh, oh, it's no longer in here. I think it's in our traits. Yeah, okay, so here's how the walkers eat. Now, the problem that I have to figure out today, or that I want to figure out today, is how do I like take in another walker? Or like, I guess like first thing is I have to determine um, is one walker inside of another walker, and I'm almost thinking of getting a getting a walker, getting an array, or I guess it would be a vector of walkers that are only not that type. So we have a name. So each of these walkers, I believe, has a name. Yeah, a name string, which means that, for example, these are all be attraction walkers. And that's hard coded in here, meaning that there's no way for it to ever not be attraction walker, which means the other ones are going to be random walkers. And so I can just say, hey, get me an array of all the walkers that exist that are not my own self. So I think that's like the first step. Give me that array. So I also need an ID system similar to what I did to the foods, so I don't also get my own list, because then I would say like, hey, I'm inside of myself. I'm going to eat myself, which would probably not be good because that's not good. So I'm definitely going to need an ID, and we'll just add that in as like this pub function new. So ID, this will be probably just a usize. So in our new function, let's go ahead and multi-line this. Okay, so we're going to take in the ID. That's going to be a usize, and that means we can just add in the ID down here. And we're going to want to do the exact same thing to the random walkers. I don't know if this needs to be public as of yet. I might actually end up using traits to sort of get the ID. So I'm just going to leave it as private for right now. Okay, so there, let's go ahead and multi-line U. Okay, so that now gives us an ID that we have in each of the walkers. So when we create the walkers, we need to now add the ID in here. But I think an issue is we need to store initial IDs. So like the next ID to use, and then we'll increment every time we use it. So here's our struct walkers. Next walker ID. This will be a usize. And when we create it, we're going to set this up as 0. And when we create the walkers, so interesting, we have this in this for loop. So we're going to put in self dot next walker ID, but we're going to have to immediately increment it now. And then use it again here. This is getting long enough that we can multi-line this too. Oh, this is interesting. Okay, so walkers push, that goes down to there. This could be right. Okay, yeah, so I see like this is one way to do this. I wonder what what is the command? I have been running cargo format recently on this. It would be interesting to see like how it wants to format it. And so maybe on our README at the very end here, we'll just run cargo fmt. All right, so we're going to do next walker ID. We increment the ID. And then, so I kind of almost wonder, would I want to have traits to sort of deal with this. Maybe? All right, so then we're going to push. Okay, you're upset, but that's I think because I'm not adding in my traction walker new. So it would be in here. You down one, you back one, you back to here. No comma for you, it's in here. So then we're going to have the next walker ID, and then we can just do this again. I mean, I'm doing this twice. My rule of 3 hasn't been tripped yet, but as soon as I need to do this one more time, I'm thinking a trait would be best, or at least a function in here. I'm probably, yeah, I don't think I'm going to need to do this somewhere else. Okay. So that gives us IDs. So when we're, things still looking good there. When I want to, let's see, now I need to get an array, no, a vector of, I guess it could be like an array slice, or just a slice of like a vector. I'm thinking a filter. So run a filter on all of the, yeah, I'm gonna have to have like a mutable, interesting. Okay, so I know I'm like sort of thinking internally and not necessarily talking about like what I'm thinking about. To determine if the walkers are eating each other, I need a list of all the walkers who are not my type and not myself. So I need a get I need a get method. So we can write that. So we can have function get get walkers other than. I'm not really sure what the best name for this is. I don't know if I need to borrow. I think I do need to borrow it mutably because I'm going to be handing a mutable reference to the walker. And so I'm planning on just doing this once, so the mutable reference should be fine. I only have like one of them. The other thing is I could potentially have in the trait for eat, I could have that just say like, yeah, I know I have a reference of all of the walkers. I'll just loop through and ignore the ones that aren't me. That might be better because I don't want to like do something weird to like get an ownership. I think I like that more because I want to get into weird ownership problems. So in our walker traits, I'm thinking we're going to want a function eat other walkers. So we're going to get mutable self, and we're going to get all walkers. And And this is going to be, so I need, oh, it's going to be because they're an enum. And so, yeah, so that makes it a little bit more interesting too. I wonder if I don't really want to do it here, but I do the eating part inside of the mod, because that will keep it a little bit easier. Here's why I'm thinking that might be a problem, is the walkers are really stuffed inside of an enum. And so if it's really just caring about itself and its own type, then that doesn't matter. But because you're going to get other types, that's actually a completely different type. And maybe the traits will help, but I need to like worry about possibly generics or other things. I'm thinking I can probably just loop through. So get to mutably reference loop through all of the walkers and then handle the eating there. I might still need some traits for the walkers to sort of deal with that, but let me see if I can write it in here. So function handle walkers eating each other. I don't know if this is a good name. This is definitely going to be a mutable self. I don't know what else I need right now. Let's not return anything at this second. So the first thing we need to do is we have our list of all the walkers. That's here in our vector of walkers. But we do need to loop through that and extract out which walker we have. So for walker in, and so here's where I want a self.walkers dot. I don't want to give it ownership. Iter mute. Returns an iterator that allows modifying each value. I think that this might be what we want, because we're giving it a reference to the vector, okay, or the array. So we're going to do iter mute. We have to give it a reference. Or maybe, okay, maybe not, because it's already a reference. Okay. Once I have that, now I should be able to figure out which walker I have. So then that's an iflet. So if let sum. So this is going to be like the walker. I'll just call this the wrapper, because it's the enum wrapper. Okay, so if some actual walker equals the walker wrapper, then I want to, let's say I just print line we'll just do the ID first. I just want to print the walker ID. All right. Expected enum walkers walker found enum standard option. Do I have to do a matchness? Did I forget how to do an iflet off of these? Oh, it's not sum. Yeah. It's, never mind. So it's not a sum, it's a walker, walker, like that, I think. Expected tuple struct variant found enum walker. Oh, enum walker, but then we also have, no, that's fine. I think matching would be easier for us. Because it would still be like duplication of code though, and so I'm trying not to do that. Found enum, because this is the enum. So walker's walker. Do I have to destructure you? I don't think I do. Expected tuple struct variant. Oh, so you just don't like the fact that I'm using enum with this? I'm fairly certain there is a way to do that. Okay, in the same way, iflet can be used to match any enum value. Iflet, oh, okay. Right, okay. So it's gonna be not exactly the same. It's gonna be pretty much just the same as a, oh, what is it called? The same as a match in this case. Because it's gonna have to be like walker, colon, colon, attraction walker, walker, like that. Which I'm not sure that's like, this is that much different than if I were to replace this entire thing with just match walker wrapper, and then I'll have walker, traction walker, like that. So regardless, I have to like handle all of these cases, and it's a little bit annoying. I'm sure there's a better way that I could have architected this, probably using different, not using different structs and different types for the walkers, but rather just handling that with traits and just having different traits, maybe. I don't know. Let's see. Okay, so if we were a walker, we now want to essentially like do the eating check. So I want to get a list of all of the other walker. Okay, so we're looping through here. I guess here is if you're an attraction walker, I now want to get a vector of references to every attraction walk, to every random walker, or to every walker that's not an attraction walker, and also not itself. So I guess that kind of makes sense here. So if I say other walkers, can I do a filter and have that properly filter out and give me the reference still? I don't think it does, because filter returns a brand new vector. But what I can, when I'm already in a loop for these. Yeah, so yeah, this makes it really interesting. I'm thinking that if I mean, I have a list. I now have all the walkers, looping through them. I could see where you are and sort of build a map of direction of distances to each other, and then compare that map. I could also create a brand new vector of that might work. I could clone all the walkers, and by cloning the walkers, I won't be able to affect them, but I can note down which IDs are being eaten and like who's eating it. Whereas and then I guess like one more loop through to find the IDs of each walker. So if I'm using IDs, probably vectors and then the enum is like not necessary anymore. I bet a hash map would have been better because I think hash maps could be any like multiple different types put together. That would be better. But I'm here, well, would it actually make sense to like do that refactor now? Probably not. So I don't necessarily want to create the other walkers here. Or maybe I do. Okay, other walkers. I need to get a clone. Basically, I'm gonna need a list, like give me all of the attraction walkers. No, give me all the not attraction walkers, not my ID. So what if I have a function where I can just do self dot get other walkers? I hand it the name, so it's going to be walker.name, and I hand it the ID, walker.id. So if I do that, let's say I now have a vector of other walkers. It's a clone, so I'm not really worried about like mutating it at this point in time, but the mutation can happen in here. Kind of. I then want to say, then I want to find out, am I eating any other walkers? I'm probably another loop here. So just like let walkers I am eating. I don't know if that's good. Because if I do that, I can't really pass the walker in. So I need to find out, am I eating this other walker? Now we could potentially use a trait on the walker. So what if I did like if walker dot is eating. Oh, I need to loop through other walkers because that's a vector now. So this is getting a little bit much. So if um, other walker in other walkers, if walker dot is eating other walker. So if that's true, if it is true that the walker is eating the other walker, we need to mark the other walker as being eaten. And then we need to increase our own size. And we can increase our own size because we're in a mutable iterator. So I can, well, I guess I could say walker.eat we're going to pass the other walker in here. But I also need to have let eaten walkers is just going to be an empty vec to begin with. And then I'm going to push in. So eaten walkers dot push the other walker dot ID. Oh, it thinks it's food. Why does it think it's food? That's weird. I guess because I haven't written a lot of these functions yet, RLS is getting a little bit confused. Okay, so if walker is eating the other walker, we then push that. We then get this sort of vector of eaten walkers. And then, okay, so eaten walkers, and then we, after this entire loop is done, so we've eaten, our walker has grown in size or health. Then we need to remove, so after this, we're going to remove so remove eaten walkers. Or actually, we already have a remove dead walkers, don't we? Where does that happen? Here. We filter out all the walkers, and they're no longer, oh, they're no longer alive. So we have to mark them as dead. And so we can do that with another iter mute. So yeah, we're gonna have to do this again here due to the fact that we have a clone, and so we couldn't update the other walker. So for, I mean, it's pretty much gonna be the exact same thing, except good morning, stacking. I'm using, yes, so I'm using my computer webcam today. Everything else is like in a box as I'm sort of rearranging the room and getting everything set up. So that's why it looks and sounds different. Like why I'm wearing headphones today instead of using actually a physical mic. Okay, so we get the iter there, we loop through you. Sounds very tinny. Yeah, I'm not surprised. It's a wireless mic. It was a wireless headphone. It's like on the side of me. Yeah, and I didn't like set everything up to try to like make it sound better. I'm hoping that this is like the only stream that's gonna sound like this. I'm hoping that I'll have like everything set up for Friday morning. Worst case scenario is gonna be Monday morning right now. Okay, Walker. Okay, so then I don't. We don't need to like get the other walkers at this point in time. We have our each of the types of walkers. Move or something. Not move, but I want to rearrange this streaming room. Sort of like pull out the desk a little bit from the wall, and I can put the camera behind the desk. I can bring my stream lights that I have like that I haven't been using for a long time uh, down from the basement where I previously was doing streaming before the accident. Bring them up here. I have a you can sort of see behind me, oh, this way, that I have like a green screen. So I need to set that up behind me. But there's just too much other things in a room that are in the way of that. So I just moved everything out of the room, rearranged all the furniture, and then put everything back in. So I mean, I guess it was kind of like a move. It's a move to myself. Sounds like I got a long, busy weekend ahead of you. I don't think it'll be that long. It only took like 2 hours to move everything out of the room, and I'm hoping that it'll be uh, like only a couple more hours to put everything back in. Okay, so we have our attraction walker. We now want to determine if the ID of if the Eaton walker matches in here. I wonder if there's any vector methods that I can use to like say like includes or inside or is. Because if I could do something like if walker dot ID, and I could even do something like get ID, but probably just ID. So if walker dot ID, if that is equal to, oh no, it would be, okay, never mind. If Eaton walkers dot, now, is there something like a includes? Or a find? I didn't see anything like that. I know that there's tons of vector methods. Maybe we should just go take a look at them. Oh, come on, bring me here. Wrestling docs. John Science, good morning. Hello. Um, hello, friend Rust programmer. Yes, I'm trying to figure out what methods on vectors. Is there anything like an includes or is? Let's see. contains returns true if the slice contains an element with a given value. Okay, that might be exactly what I want. No, I'm not planning on merging vectors, but what I want to do is I now have a vector of IDs, and so I want to match, okay, if the vector, so if contains, and then it's going to be walker.id. So if that's true, then I want to mark the other walk. Okay, I want to mark the walker as dead. This is upset. Oh, it's private. Yeah, that's fine. I'll fix that in a second. Then I want to say walker dot. I mean, basically, like was eaten. I don't know, just like a little method on a trait that I could add in that will like flip it from is alive to not is alive. I probably want to like prevent double eating just in the case by, I can't necessarily do this right away. Yeah, I'm not gonna worry about that right this second. All right, let's get these errors out of the way and let's see if that actually solves the problem. Solves our problem. Okay, so get other walkers. This doesn't exist. This is going to be just a function that we have in here. This will be a vec of, I guess it'll be a vec of, oh, walkers of this very specific type, isn't it? Oh, and I see like, okay, it's walker, get other walkers. I give it the walker name and the walker ID. Okay, got it. Okay, yeah, so that's going to be, ooh, I don't want to create a function. Okay, so like one way to handle this, it's a bad way to handle this, is I could say get other attraction walkers. But then down here, I would need to do the same thing and say get other random walkers. Or I guess this is like not, actually this is the opposite. This is get other walkers is everything but attraction walkers. And that's still gonna be the enum problem. So I think we have an architecture issue because of my initial thoughts to like make it easier for myself to have a single vector that holds all the walkers. So that way I can loop through them. That is not an optimal way of storing the walkers, because vectors can only hold one type. So to get around that problem, I created an enum. And the enum allows me to have the vector of that enum, and then I can extract walkers out of that to like do things to them. But when it comes time to eating each other, they need to be able to essentially like be aware of each other. That's a problem here because they're wrapped inside of an enum. And I can't just give this a vector of other walkers, because eventually I'm going to have a third type here. I can contain union, can't I? Well, the contain, I don't think the contain is the problem. I think it's more of like in here. When I'm looping through, I can't actually, like this get other walkers is not going to work the way I want it to. I think what I need is a hash map. And let me make sure I'm correct. Can it be whatever types I want? Or is that also not true? Let's see, creating a new hash map. See, okay. So it would be the same problem because I would have like string string. So this would be like, I could have the ID, but then it would be the type of it would be different on the other side. And I could just have multiple hash maps. Hash map, the key should just be a generic. Oh, interesting. So I can do a generic with hash map. Yeah, So if I did a generic with hash map, I kind of want to. Oh, this is when like Danny gave that interesting thing. We can actually use this because we have our struct with some interesting stuff here. Do I have to use? I think I have to use. Use standard collect. Okay. Collections hash map. Is that it? Nope. Yeah, that's it. So then I can create a hash map new. In here. Okay, so if I do map equals hash map, oh, and I guess I'm going to have the type. I think that would be, which side is it? Is it here? And turbofish syntax here, or is it on the left? And we do, Danny, good morning, turbofish, yes. So let's say I do like usize for the ID. And I do T for this. For that type. I don't know if that's going to work. And then I can say new, like you. Will you just yell at me? Can I find T in the scope? So then in this case, would I have to have like the main function know what like T is? No. Patterns aren't allowed in methods without bodies. Wait, these are warnings. Okay, so no full errors. I'm actually surprised that there's no full errors. Match 5? Good morning. Also, Katali, good morning. Maybe it can be generic. I don't know. Now, can I insert into this map? So we have this random walker that we created here. Can I give ownership of the random walker to the hash map? So I'm going to say map.insert. 0 and random walker. When I insert, is that an option that I need to handle? No, it is not. So if I do that, and then we do the same thing to the attraction walker, we're not going to print the position here. You can have a generic main, Rust just won't run it. Wait, Rust won't run this? And now I want to, we have the trait for get position, so we can just use that because that's shared across both of them. So the compiler should be okay with that. So I want to do the iteration through the hash map. Is there an iter visiting all key value pairs in arbitrary order? The iter element type is key and value. Okay, so I can just do that. Oh, and there's the iter mute too. All right, so for it's going to be the ID and the I guess the walker in map.iter, and I want to print line ID for walker Okay, so if I have, this is going to be the ID, and then the walker dot get position dot 0. Let's just do the X. I don't know, maybe I can do that. Maybe tuples have the ability to be displayed. Do you think so? Void is a type, isn't it? I guess. No, void is not a type in Rust. There's an option none, but there's not a like a null or void type. Okay, so if I just do this, I keep on hitting save. Will you run? Mismatch, okay, so mismatch types. Expected type parameter found struct random walker. Expected type T found, okay. That's interesting. Oh, you have, okay, so we have T. I don't know if I can do like the colon with the type because I don't know what type, what it is. Oh, we know it's type that implements that. So like I have position without. Expected type parameter found struct random walker. Am I just doing this wrong, or is it because I'm in main? Or is it like a combination of both? Oh, and of course it wants me that, but that's not the problem. I could create another struct that holds both of these and then implement on that. Okay, so what if I, Crossbow, good morning. You're not good in Rust, but for me, it seems that you need traits for walkers like eat, walk, and similar traits. I have some of those. I guess the problem with the trait for eat is I need to pass it the other walkers. And like that's what I'm running into right now. If I pass the other walker in, well, I guess we can experiment with that here too. Is if I have a trait, trait position, I'm just gonna overload position here. In the other one, we just have like walker traits, which would kind of be what we want. If we have something like eat, because we want self, and we want like the other walker. This would have to be a generic, but I think what we found out is that I don't think we can do generics in traits. Because I don't think I can do something like a trait, which is literally trait of position. It would be something like this here. Because I think we ran into the problem where we can't do traits. We can't do, or can we? Eat other walker T. This might be something where I need to go and do some research off stream, to sort of see how to do that and what ways to do. Let's see. Eat other walker. Even if I don't return anything, let's say I have like the generic, like this is the default implementation of it, and I was to say, and this is getting ownership over here. So like even if I wasn't doing anything clever with references, and I just wanted to say, I don't know, I am eating, I have to like get the name. Can you make that generic be something with multiple traits? Ooh, interesting. Maybe. I don't know how to search for that properly. Traits bound on generic functions. So there's has area and then the type. I'm not seeing like multiple. Can I use the same trait twice? Ah, plus. I can do plus to bind it to multiple traits. That's how to do it. So I could do another trait and add that in here. it leads towards like, I still need to figure out the proper, if I need to change the architecture on this. Because I think the looping through might be causing me to have a little bit of trouble. If I don't, like, a vector has to have like a single type, well, that might be another question is when you're using the generic with the hash map, is it still able to handle multiple types in a single hash map or in a single vector? So let's say I start over here. Let's say I have like a struct A, struct, I'll just say this like first, like 1, and I have an ID, which is usize, implement 1. I guess I don't really need to have like the implement on it to create a new one. And I have a struct 2. We could do name instead of ID. I'll just have this be a static string. Are you okay with that? Oh, no main function. Expected state. Oh, I always forget how to do like the static string. Can you explain what the current problem? If I understand your problem is that you need to iterate over walkers in different types and that they eat each other. Yeah, so that's my problem. Right now, I've sort of coded myself into a corner. What I have is in my main sort of like controller structure for all the walkers, I have a vector of the walkers. But to get around the multiple walker types, I created an enum. And the enum holds like the random walkers and the attraction walkers. But now I don't have just a vector of the walkers, I have a vector of walker wrapper essentially. And that makes it a little bit interesting when trying to now like extract out, loop through them. Because when I loop through this vector, I don't get walkers, I get the enum walker. Then I have to extract out and I get one of random walker or one of attraction walker. And in the future, even more types would be added onto that too. So if I could do like a vector of a generic and then hold multiple things together, I can get rid of the enum. And then that would allow me to just loop through it. I can hand all the other walkers. We can make sure it's of the same traits, like has the same traits, which are going to be these walker traits. So all the walkers will get this trait. And that would allow me to then ease like a little bit more easily. So I don't have to like do two, like a loop and then an extraction through, which is making the code really complicated. So my experiment is, if I have like these two structs, I guess I'll just have this be a string. And I need function main. And if this function main, I want to create a let, I guess I'll just have like a holder struct. Because like the main and generics is kind of a little bit weird. So if I have, and you are going to, because this is kind of how I want to hold it. Imurania. I think I pronounced that right. If you understood correctly, you can do that, but you will have to box the elements in the vector so that they are sized, which then would be the exact same problem, right? Because then they'd be inside of, well, maybe it wouldn't be the same problem. I think before continuing to write code, I need to understand this, like the shape of my problem first. And I think that's where like playing around in this playground comes in. Is okay, so I have my controller and I want to now hold all of the the things. And let's say let's do like the beginning one would be a vector. So if I want this to be a vec of type t, and I can have it be like a trait of like, what is it? Things. I don't know. Maybe we'll just do like has name. I don't know what a good test thing to do. Which means that I now need to create a trait for these. So trait has name. I mean, I can just do is thing. And so we're going to have a function like get name. It's going to be self and returns we'll just say it returns a string. I'm not going to implement that, but we're now going to say, okay, for you, I want to implement, I guess instead of I do this, let's just do cool name. I want it to be different than the other name. So I guess it could be the same. Name string. Implement thing for one. And we now need to implement get name. Yeah, playing around in the playground is the best way to design it, or at least to understand like how these things work better than just playing around in my existing code base, which will just lead to tears, and probably worse than what I have right now, unless I got really really lucky. And so all I'm going to do is I'm just going to return self.name. I'll just clone it. Yeah, I'll just clone it. Okay, so then we're going to do the exact same thing here. But for 2. All right, so that gives us 2 different types. They have the same trait on them. And so here we have our controller structure. And what I want is like to hold all the things, and there's going to be a vector of type like that holds thing in it. So can I now I guess I want to implement all right, so let controller equals controller, and then we're going to have our things, and that's going to be a vec bang, and we're going to put in, so let's maybe create our first struct. So 1 equals 1. Name is 1. Oh, and this needs to be to owned. Okay, so I got my 1 and 2, and then in here we're gonna just give you ownership. So here's 1 and 2. You can own it, controller and vector. So I guess like to begin with, I know there'll be warnings for like not, well, these are used, but controller, will this compile essentially? That's the question. And the answer is no. Error, associated type bounds are not allowed within structs, enums, or unions. Okay, so this is where we're saying that we need to box it. Associated type bounds are unstable. For more information, see this. Wrong number of type arguments, expected 1, found 0. Associated type bindings are not allowed here. So all sort of the thing. If you remove the T and only do vector of thing, well, thing is a trait, but let's try it. Let's see what happens. The size for values of type dyn thing plus static cannot be known at compilation time. So this is where we need to box it. So it knows how much memory to reserve. Oh, interesting. It's auto applying the dyn type. It's like this is the same as me saying this. Yeah, okay, I think it is. I haven't used the dyn type before, so that's pretty cool. So now I need the box type to box it up and store it. The auto dyn is maybe Rust 2018. Raven Legend, good morning, hello. Okay. So we have we're storing like the dyn type for thing. So it can be 2 types in here, but because the types are sort of unknown, then we're gonna need to store it to box this up. Do I need to pull in box? Can I just use it? Do I have to use? Okay. Stay in here. Okay, so what if I did let boxed 1 equals box new 1? Is this how I can do it? So this becomes boxed 1, box 2. Expected value found struct box. Okay, so now this is a problem because, well, I guess it's not that big of a problem. We can say, okay, it's a vector of boxes. And the box is going to be thing. Expected value found struct box. Constructor is not visible here due to private fields. Possible better candidates are found in other modules. You can import them into scope. Oh, like one of those. Oh, wait. Did I do colon? I need colon, but that's not the problem because the first one had, oh wait, no. Let's just try this. Okay, only warnings, no errors. Okay, so that's a good sign so far. Thank you, Matt and Danny for the two colons. I don't get the Twitch highlighter in this view. All right, so this allows us to sort of not use the enum anymore. When I extract it out, I guess so that would be the next thing, right? Is I want to now get things out. So if I just want to grab a random one out and then print, print the name. So how do I do that? It's been like I only use boxes in the book, so I haven't used them in over a year. And there was a break between them too. So if I want to say, oh, this would be probably on an implementation off of controller. So implements controller. So let's say we're gonna pub function, we're gonna print names. I'm not gonna return anything, I'm just going to print straight out. And I'm gonna say for thing in self.things. So this gives me thing as a box now. I don't think I can just like reach directly in, but like maybe I can. I don't remember enough about boxes to know like what cool things it allows me to do. Is like box a struct where I can just grab the thing inside? I could just look at the documentation. So we create a new box into raw, which gives us a pointer, but that's unsafe. There's from raw. Oh wait, that's okay. That's still unsafe. I want to avoid unsafe if I can. All these examples are using safe, or unsafe. This consumes the box. That's not what I want. Into pin is nightly only, so I'm not going to even look at that. Downcast, attempts to downcast the box to a concrete type. You can deref with asterisk elem. Wait, can I deref the box itself and then I get the thing? like, keep on switching over. Um, so, I mean, I don't think I can just do print line. So this would be dereft thing dot get name. I don't think this would work. The size for values of type stir cannot be known at compilation time. Trait objects without an explicit dyn are deprecated. So, okay, it does want me to like explicitly state that that's a dynamic. Boxes implements deref. Oh, awesome. The size for values of type stir, where is that? Print item name, things like get name, doesn't have a size note at compile time. I want these to be actual strings. Interesting, okay. If you remove the deref. I keep on hitting save. Cannot move out of self.things, which is behind a shared reference. Okay, so what if is there like an into mute or iter mute that I can use here? Cannot borrow self.things is mutable. It's behind, which means you need to be mute there. It compiled, so then I want to run this. So we store them, and then we're going to say controller dot print names. Cannot borrow controller as immutable. Okay, so we need to mute controller there. No main no main function was detected. What's the difference? Lowercase m. Oops. Well, okay. Okay, that's pretty good. Okay, so we can use the box. So we could use the box. We can use the vector. This, I think this would work pretty well. I could probably also use a key value pair with a hash map. So if we come back and we take a look at our code, we have this enum. Basically, we get rid of the enum. We have a trait, walker traits, that's assigned to all the walkers, and we know that. So that allows us to do this thing, where we're going to use the dyn trait, or the dynamic type with the trait, and then we store these in the box. So the walkers won't be a vector of these walkers. It would be a vector of dyn. We have to get the walker traits, walker movement. If I add like, I guess I should probably, like, this is getting a little bit, this is like pretty much walker, like all the walker stuff, I would replace the enum walker, and this would just be a trait walker. Oh, and you would need to be a box like that. Then I can just sort of use you the way I sort of expected and wanted to initially. So basically, yes, you can either use static dispatch with an enum, and then you have to use match or dynamic dispatch with a box interaction and a common trait. And I think the dynamic dispatch is what I want to use here. Unfortunately, I am out of time. I do have my stand-up to go to, so I'm not going to be able to finish and like actually do this today. But what we can do, we didn't like. I don't think I want to actually implement any of the stuff that we did today. What I want to say is walkers can eat each other. Before this, remove the enum, use a box dynamic type and the trait. So if we do this, it'll make it a lot easier for us to I think also I might want to switch over to use a hash map. The reason for that is because now I'm going to need IDs for all of the walkers. I might as well just throw them into like instead of a vector, a hash map. So remove the enum, use a box, dynamic type, hash map, and the trait. And then we can implement walkers can eat each other. So I'm going to save you. I'll save you, but then I'm going to immediately come to, what do we have differently? Yeah, so we were implementing IDs. I think I want to just sort of discard all of these changes. I will do this next time. The README is the only update for this. So we figured out what we are going to have to do next time. I'm going to push that up. I do have a link to the code down below or in the description. If you're on computer, I think you can see a much nicer interface for it. Otherwise, it's just a link in the normal description to where I have everything on GitHub. I'm doing these streams every Monday, Wednesday, and Friday in the morning. So that's 6:45 a.m. Mountain Time, which is now GMT -7, which is why it's like so bright in the room, because like there's light coming in from outside, which will not last for very long. So we have this. Is there? Pause you immediately. Nobody I'm following is online, it looks like. If I do you, yeah, nobody I'm following is online. So I don't think I'm going to do a raid today. But that being said, I hope that you all have a great rest of your day, and I'll see you next time. And yeah, that's it. That's all I got. Bye.